Auzubillahiminasyaitanirrajim. Bismillahirrahmanirrahim. Assalamualaikum. Salam Malaysia Bandani. Good day to all panel and participant. Okay, so my name is Wan Muhammad Yaakob bin Wan Bejuri. So here I'm with Associate Professor Dr. Mohamad Murtadha bin Mohamad. So I'm from University Technical Malaysia Melaka. Meanwhile, Associate Professor Dr. Mohamad Murtadha from University Technology Malaysia. So together we are here to present our innovation in EREKA. Here we go. Okay. So this is our invention title, which is additive noise and sample size spatial strategy resembling particle filter for initial sensor based rapid flood emergency response. Okay, so this is the summary of the our technology or innovation. Okay, so basically urban flooding is worldwide frequent hazard. So throughout this hazard, it causes financial losses. Frequent commuter also infected. So here, various technique has been applied to estimate the flood level. One of the low-cost solution, which is an initial sensor-based system, can be used to retrieve the flood level and respond to the warning message to the user by sending it to the cloud. However, the data processed by initial based system might be suffered from the sample environment phenomenon, which is caused by sensor sensitivity and real-time transmission. In this project, we aim to design a new particle filter and implement to the system of initial sensor based rapid flood emergency response. So this system or design will be based on the additive spatial strategy resembling particle filter. This is to optimize the data input, thus can increase the flood level estimation and finally can share the alert information with other users. So in order to do this, numerous volunteers will take the reading as more than 10,000 reading in different depth level. So then it can be used to train machine learning model. Finally, it is expected that the proposed algorithm can achieve impossibility and robustness in different kind of human movement. So our aim in this invention is to design a new particle filter algorithm for initial sensor-based rapid flood emergency response. So this algorithm named as adaptive noise and sample size spatial strategy resembling particle filter. So the design is based adaptation, okay, of noise and sample size retrieve data input. In order to do this, so basically there are three types of spatial strategies resembling particle filter that can be implemented in initial sensor based rapid flood emergency response. First one is weight modification. Second is sample size modification. Meanwhile, the last one, which is third category, is third or state modification. So in this project, we aim to propose spatial strategy resembling particle filter based on three different features, which is weight, state, and sample size. Okay, so these spatial resampling strategies will be switched based on situation of sensing. Okay, so this is how the algorithm will be look like. As we can see in the right part, this one is showing our flow chart. We start with the start, and then second we'll obtain or measure the noise measurement and the particle sample size. Particle means data, and then after that, if the noise measurement is high or sample size, okay, and then is high, it will it will go to under that. After that, if the current noise measurement or current sample size, which is less than 0.1 and less than 80, it will go to here. If the current noise measurement less than or equal with 0.1, go to here, which is it will doing the rough base resampling. If no, you will go to the if current sample size less than or equal with 50. If yes, you going to the variable size resampling, which is a modified apa ni? No, which is a KLD variation resampling. If no, you will go to the modified base resampling. So this is for our algorithm, which is how the algorithm will works. Okay, for the architecture system, so this is showing the architecture system lah. Basically, we divide the system into three different module. First is a sensory, second is the processing, and the last one is the storage, which is database lah. Okay, for the sensory subsystem, we use the geolocation sensor and initial sensor, and then it will process the location data and the initial data, which is the initial data based on the activity recognition, how we walking. Okay, and then the data will process by the sensor, by the processing component, which is a CPU processing unit that located in the mobile application. Okay, and then it will process, okay, based on the if the water level via re get recognition, for example ankle, calf and knee. Okay, and then after that it will also refer to the database subsystem. We look up the information inside the storage. Okay, so as analysis, we depict the behavior of proposed equilibrium with other special strategy particle filter that using modified resampling, variable size resampling, roughening resampling in different scenario. Okay, so this is the scenario. Okay, and then the proposed resampling, which is APF, achieve the lowest RMSE during the fourth simulation and the second lowest RMC during first simulation, second simulation, third simulation, and fifth simulation. So this is because the scheme has the capability to change or combine resampling operation according to the sample information situation. In terms of performance improvement, it is clear that the APF achieve a better performance than existing resampling scheme. In particular, the particle filter scheme, I mean the additive particle filter scheme, reduce RFC by 6.44%, 14.47%, and 7.32% in comparison with modified base resampling, variable size resampling, and ruffling base resampling respectively. Okay, so as a result, our algorithm achieve an average improvement of 7.26%. So the reason for such improvement is that our algorithm consider different situation of high sample involvement. Okay, high sample involvement in which it able to carry out modification of particle sample size, particle state, and weight in different situation in high sample involvement. However, our proposed algorithm does not only consider specific zone in high sample information. Okay, so this is our result. Okay, so this is our application lah. Okay, so it will show based on the activity movement, it will show the or estimate the level of the flood, okay, end user, and update the information to the cloud, and then the information the cloud will be shared to all user. Okay, whether to the computer or whether to the administrator of the system, so that the administrator can can have an alert lah. Let's say if I have a flood, okay, and then the administrator will do the action by maybe clear the flood, at the pedestrian, for example, like that lah. Okay. So why it need be to protected? So it needs to be protected because we can produce valuable software from it. Okay, and then we expect the commercial potential expected value creation around 20,000 something. Okay, and then we want to do the collaboration government sector such as NATMA. Okay, actually we want to do lah. Okay, this is our future. Okay, so as a conclusion, we can actually basically the aim of our algorithm is to achieve RMSE RMSE reduction across different situations in high sample environment. Okay, so in order to do this, the concept of adaptation of the particle sample size and noise measurement into integrated spatial strategy resampling has been proposed. So in our algorithm, the noise measurement and particle size will be of 10. So then, if the noise measurement is low, the scheme will switch to the roughly resampling scheme. However, if the particle sample size is low or moderate, the resampling task decision is depending on the particle sample size. So at the end, the APS scheme will carry out the resampling procedure based on the modified best resampling or level size best resampling. So the APF scheme has been compared with previous spatial strategy resampling scheme. Okay, the experimental result demonstrated the APF scheme has better performance in terms of resampling reduction across different situations during high sample enrichment. Okay, thank you. So now we want to show the system demonstration. So here I will show I will already do the recording, okay, about our demonstration. So here I will do like maybe walking inside the flood, okay, and then uh, the application will recognize the activity what I'm doing, and then you will do the estimation, the flood level. Okay, so this is at the right is this is the showing the screen mirroring about our application. Okay, which is located in my mobile phone. Okay, so now we play the video. Okay, so that's all. Thank you very much. Okay, so as we can see here, this application showing the water level of the flood. Okay, so here is at the knee level. Okay, which is the flood at the knee. Okay, okay, so that's all for my presentation. Thank you very much.